Welcome back students to the chapter Chemical Bonding and Molecular Structure of class 11. So this is part 4 of the chapter, and in this part we are going to see how to draw Lewis dot structure of a molecule, of a simple molecule. How to draw Lewis dot structure of a simple molecule. So in this part we will see how to draw Lewis dot structure of a species. Why it is written species here? So it can be a molecule, it can be a neutral molecule, or it can be a charged species. So whether it is a molecule or a charged species, we will learn how to draw its Lewis dot structure. So formula of the species will be provided. We will see the steps how to draw Lewis dot structure from the formula. So here I am taking an example, that is carbonate anion. So CO3 2 minus, CO3 2 minus. So I have in this CO3 2 minus I have 1 carbon, 3 oxygen atoms and a 2 minus charge. 1 carbon and 3 oxygen atom and 2 minus charge. Clear? So I am going to draw the Lewis dot structure of this compound. So how is this? How many bond pair is there? How many lone pair? How is it structured? These are the things that I am going to learn here. So first thing is I am going to calculate. So according to Lewis, Coastal-Lewis approach, what is the reason for the stability? What is the reason for the stability? Stability reason is octet, isn't it? Reason for the stability is octet, which means that each atom in the species must have 8 electrons. Each atom in the species must have 8 electrons, isn't it? In order to have an octet. So if each atom wants octet, how many electrons must be there? So I have 4 atoms. So if each atom requires octet, which means that each atom must have 8 electrons. So 4 atoms are there. 4 into 8 is equal to 32 electrons, isn't it? I have 4 atoms and each atom must have 8 according to Coastal-Lewis. So that means the molecule must have 32 electron. So I will write it. I have 1 carbon. It requires 8 electron for the stability. I have 3 oxygen. Each oxygen requires 8. So it will be like 3 into 8. That will be 24. So 24 for 3 oxygen and 8 for 1 carbon. So there should be, in total, there must be 32 electron for the molecule to have octet. So that's the first step. That's calculation is the first step, calculating total number of electron required for the octet of atoms in this species. Clear? So we will do the same calculation again here. How many atoms present in the species? 1 carbon and 3 oxygen, a total of 4 atoms. And for each atom it requires 8 electrons. So there are 4 atoms. If it requires 8, 4 into 8 is equal to 32 electron, which I am representing use the symbol octet electrons, O subscript E. O subscript E means octet electrons. So the number of electrons required for octet is 32 electron for the species. So OE is equal to 32 electron. So I have calculated OE, and the OE required is, in the previous slide we have seen, it is 32 electrons. Now next what I'm going to see is how many electrons. It requires 32 electrons, but how many electrons does this compound have in it? How many electrons does this species have inside it? How to get it? So calculating available electrons in the given species. So available electrons is given as V subscript E. How to get this V available electron VE value? So what I have to do is I have to sum up the valence electrons present in the atoms. So which are the atoms present? So I will write it down. So there is carbon and there is 3 oxygen. So I have 3 oxygen atoms, isn't it? So I have to calculate, I have to sum up the valence electrons. How many valence electrons does carbon have? Does carbon have? It is 4. How many does each oxygen has? So we will calculate. This has 4 electron, this has 6, this has 6, and these two have 6 electrons. Clear? So if you sum them up, what you have is 22 electrons. 6 plus 6 plus 4 is equal to 22 electron. And if you are looking onto the species, apart from these atoms, we have an additional 2 minus charge. So apart from these atoms, apart from these valence electrons, I have additional 2 minus electrons. So how did the carbonate get this 2 minus? Maybe the compound is like this. The real compound is like this. It may be calcium carbonate. Okay, the compound is calcium carbonate, and this is a ionic compound. So calcium might have given away 2 electron, and it is now a species, that is Ca2 plus. So what happened to that 2 electron? It is accepted by the anion. Anion is CO3 2 minus. So thus, apart from its valence electrons, CO3 has an additional 2 electron from the species, that is the counter ion. We call this as counter ion, the species that is cation. So he has got this 2 electron from his partner. Clear? So total number of available electrons means you have to add that electrons also. You have to add that electrons. So the total number of electrons with that additional 2 electrons, it will be 24 electron. So is it clear how to get the available electrons? How to get it? You have to calculate the valence electrons in all the atoms present. Carbon has 4, oxygen has 6. So if you sum them up, you have 22 electrons. In addition to that, you have to add or you have to subtract if there is any charges. So why I did the term subtract instead of adding this one? What should I do? I should minus. Then minus of minus only, then it will become plus. Clear? So I have to subtract the charge from the total number of electrons. If I am subtracting minus of minus, because the charge I am getting is electron. So in order to numerically make it correct, I have to subtract the charge. Then it will be a plus. Minus of minus will become plus. So 22 electron plus 2 electron is equal to 24 electron. In typed version, how many atoms are there? Total of 4 atoms, 1 carbon and 3 oxygen. And each carbon, and how many valence electrons? Each carbon will have 4 valence, and each oxygen will give 6 electrons. So 4 from carbon and 6 from oxygen. We have such 3 oxygen, so total of 18 plus 4 is equal to 22. Clear? Number of valence electrons available in the molecule, that is 22 electrons. Next, what is the charge of the species? What is the charge of the species? CO3 2 minus. So charge of the species is minus 2. So how to get the available electrons? What you have to do is, this is an explanation how it got the charge. Negative charge means species have additional 2 electron that it has gained from other atoms. As I said in the example, it has gained from other atoms. Now available electron VE is equal to, is obtained, total valence electron, that is 22, minus charge on the species. So minus charge on the species is minus of minus 2. It will turn into positive. So by substituting these values, 22 plus 2, you will have 24 electrons. So the value of VE is 24 electron. Value of VE is 24 electron. And what is expected? Expected value is 32 electron. But what we have inside the molecule is only 24 electron. So what is the next step? So we have what is required is 32 for octet for all the atoms, and what is inside is only 24 electrons. VE is only 24. So how much electron is required, or how much is the shortage, how much is it deficient? So shortage of electron for octet is equal to OE minus VE, that is 32 minus 24 is 8 electron, which means that carbonate species, this species requires another 8 electron to complete its octet of 32 electron. So what will he do? He will try to share that electrons. This 8 electrons, which is actually a deficient thing, they will try to share that 8 electrons between the atoms in the species. So number of electrons that are deficient must be shared between the atoms in the molecule or in the species to attain the octet. Clear? So and they are shared as bond pair. Sharing of electron makes a bond. Sharing of electrons, a pair of electron makes bond pair. So if we have 8 electrons, if they are shared, we will have 4 bond pair, isn't it? If we have 8 electrons to be shared, then number of bond pair formed will be divided by 2. Divided by 2, that is equal to 4 bond pair. If there are 8 electrons, then number of bonds that is formed from this will be 4 bond pair. So therefore the number of bond pair in the molecules, how to get it? How to get the number of bond pair in the molecule? So you have expected value, that is 32, and you have the valence electron, that is 24. You simply divide it by 2. So OE minus VE by 2. That difference is to be shared. You divide it with 2, then you will get the value. So by doing that, 32 minus 24 by 2, you have 4 bond pair. So we have 8 here. 8 divided by 2 will be 4 bond pair. 8 electrons, which means that, so I have this formula, and using this formula I can calculate the number of bond pair using the formula OE minus VE by 2. So when you are getting a molecule, what you have to calculate is OE first, then I have to calculate, OE means the number of electrons required for octet, and VE the available electrons in the molecule, and then divided by 2, then you will get the number of bond pair. This is the crucial thing while drawing Lewis dot structure. Okay, so we will see that. Step 4. So now we have following information. So informations like I have number of bond pair OE and V I got. Then from that I have calculated the number of bond pair. And what was the number of bond pair? No, bond pair means the shared pair of electron is equal to 4. There are 4 bond pair in the molecule. Okay, now I am going to make the framework of the molecule. This is crucial, and we should know at least something about the structure of the molecule. We should have some previous knowledge which you will acquire while we work out various Lewis dot structure or Lewis dot structure of various molecules. You will come to know the structure of the compounds. So one thing what you can remember is that whenever you draw a structure, a framework, electronegative atom, less electronegative atom, which means that the electropositive atom must be the central atom. So there is an exemption if there is such, which we will see that later. So always when you are drawing the structure, in the structure the central atom must be less electronegative atom. The central atom must be the less electronegative atom, and the more electronegative atom are distributed around this central atom. Clear? So let us see the case of carbonate. In the case of carbonate, the less electronegative is carbon, more electronegative is oxygen. So I have distributed in a way that carbon is placed in the center and oxygen surrounding it. So carbon is placed and oxygen surrounding it. And I know that how many bond pair are there? How many bond pair are there? There are total of 4. Now I am going to distribute this bond pair between this carbon and O. Between carbon O, between carbon O and so I have 3 CO. So I have 3 CO pairs, but I have 4 bond pair. So what I will do, bond pair of electrons are evenly distributed. So I will distribute them evenly between the central atom and the adjacent atoms. So I will distribute the electrons evenly between the central atom and the adjacent atoms. So let us see how to do that. So I have distributed like this. You can distribute as per your willingness. The only thing is that it should be even. So I have filled one pair here, filled one pair here, I have filled one pair here. So I have one more pair, that is fourth pair. I can go for any one of them. But don't fill all the pair in between one CO, between one CO. Try to fill one pair each first between all the CO pairs, then start filling the next one. So I have filled up to here, then I place the next one here. Now this pair of electron is a bond pair which actually owns by this oxygen and this carbon, and this pair is owned by this carbon and this oxygen, and this pair is owned by this carbon and this oxygen. Clear? Which means that all these pair that is shared belongs to carbon also. Now try to count the number of electrons. Now carbon has 8 electrons now. So according to Lewis, Kossel-Lewis, 8 electrons are required for octet. So that means carbon is now satisfied. So satisfied atoms are circled like this. Now carbon is satisfied because it has 8 electrons and it is sharing all these electrons with 3 oxygen atoms. Now looking on to one of the oxygen atoms. So we will look into this oxygen atom here. He is sharing a pair of electrons, which means that he has only now 2 electrons. Now what he need is 8 electrons. So additional 6 electrons I will draw here. So I will draw additional 6 electrons, which I normally call it as lone pair of electrons. So 3 lone pair of electrons I have drawn. Now for this oxygen, 3 lone pair and 1 bond pair make the octet. So once the octet is complete, I circle them. Now moving on to the next oxygen. Very much similar like this. This oxygen have only 2 electrons. So to make it octet, I draw 3 pair of lone pair. Now once the octet is complete, I circle it. Next is the last oxygen, which has already 2 pair of electrons, which is being shared by carbon. So this is a double bond. If there is 2 pair, this is double bond, this is single bond, and this is single bond. And in that we have 4 electrons, which means that in order to complete the octet, oxygen here requires 2 pair of lone pairs, so which I will give them. Now for this oxygen also octet is complete. Once the octet is complete, I will circle them, which means that all the species now have the octet. Clear? Now what I need is a verification. I need to verify the compound. How to verify it? I have calculated in the previous slide the number of VE, valence or number of electrons available, VE, and if you remember it was 24 electrons. Number of electrons that is available for this particular species was 24. What I have to do is I have to verify this. How to do that? You just count the number of electrons. So first you count the pair. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 pair means you have 24 electrons. So it is verified. Clear? And by 24 electrons I have succeeded in making the entire atoms, providing entire atoms and octet. So we know that we have seen this species has a -2 charge. I have to give that charge. How? Just draw a square bracket around it and provide 2-. Also you can avoid writing this or drawing this circle round. So if you are giving the bonds, number of bonds, here there is only one bond. So if you are representing using single line, bond line, then you can avoid this. So how to do that? Like this. So carbon, single line, here there is double line. So here it is on the left, but in this case, so it can be any oxygen. This double bond can be this one or this one. Accordingly, the number of lone pair must be different. Clear? And the last one, instead of showing lone pair, you can just represent the molecule with just the bond pair of electrons. So this is a special case, but if you are asked to represent Lewis dot structure, you are not supposed to show this structure. So this is not supposed to, you are not supposed to show this structure when you are asked to draw Lewis dot structure. You are supposed to draw either this one or this one. This one is wrong. If you are asked for Lewis, if you are just asked for structure, you can draw this, but if you are asked specifically for Lewis dot structure, you are supposed to draw either this one or this one. Either of the both will do. Okay, so that's about the Lewis dot structure of carbonate anion. We will look one more example before completing this part. How to draw the Lewis dot structure of ozone. So as you know from the formula of ozone is O3. How to draw it? So I need to calculate the number of bond pair, isn't it? So number of bond pair, how to calculate it? I need to have two variables. What are they? So O3 has three oxygen atoms, and I need to calculate OE first. What is OE? Giving 8 electrons each for all the atoms. Clear? So I have 3 oxygen atoms. If I am giving 8 electrons each, there must be 24 electrons. For its octet, there must be 24 electrons. And the next is VE, the total number of electrons that is available for ozone. So here there is no any charge. What I have to calculate is just sum up the valence electrons present in 3 oxygen atoms. So each oxygen has 6 electrons, so 3 into 6 will give 18 electrons. So what is required is 24, and what I have is 18 electron, which means that there is a shortage of 6 electron. So these 6 electrons will be shared, and 6 electron will make 3 bond pair. So how to calculate the bond pair? Number of bond pair in the molecule is equal to, we have seen the formula, OE minus VE divided by 2. OE minus VE. So OE I got it, and VE also I got it. So I am just substituting it, 24 minus 18 divided by 2. So this is an important formula. This is the formula that is crucial for Lewis dot structure. So you should note it down. So you should circle this formula if you are writing the note. Okay, because this is the crucial formula, and you should know what is OE. OE is number of atoms into 8. And what is VE? That is total number of valence electrons plus charge. Here there is no charge for this species, so total number of valence electron. Each oxygen has 6 electrons, so 6 into 3 is 18 electron. And we will get, if I know OE and VE, I can calculate the number of bond pair. 24 minus 18 divided by 2 is equal to 3 bond pair. Next is, I know now the bond pair. Next I should know the structure of ozone. That is important. Or the framework of ozone. So what is the framework? It is just like this. But in real life, it is not the framework. In real life, I will show the framework. How will it look like? So it looks like this. O and O here and one O here. It is just like an inverted V shape. Clear? So we have, instead of this, I am just showing it in a straight way, that is O, O, O. So we have 3 oxygen atoms. I am placing them, and I have 3 bonds. Now I will evenly distribute. I will distribute one O here, I will distribute one O. then remaining one more bond pair, one bond here, one bond here, between this O and between this O, and one more bond pair is there. I will randomly place them. So I will do it like this. One between these two O and two between. So I have now three bond pairs placed between them, between the atoms for sharing. Now I'm taking individual oxygen. So this oxygen has now 6 electrons, isn't it? From each pair he will take 6 electrons, which means that 2 more electrons will give it the octet. So 2 more electrons. So there is only one lone pair for this oxygen. And for this oxygen, it has already 4 electrons. So it requires another 4. Means 2 lone pair is required. I am providing it. So his octet is also complete. Next is this one. It has only one pair. So it requires 3 more pair. I am giving it as 3 lone pair. Now if we want to verify how many electrons are there, 18, and it must be have only 18 in this. So let's calculate 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pair of electrons will give 18 electrons. 9 pair means 18 electrons. So I can draw the same thing using this structure. How to do that? So the same thing. So I will draw one bond pair here, one bond pair, and additional bond pair I am choosing this time this side. So this oxygen here is having now 6 electrons or 3 bond pair. So I will put the required additional one here. So 2. So octet is complete for this one, and in this case it has only one pair. So I will give rest of the 3 pairs. So octet is complete for this, and here it has 4 pair and 2 more additional bond pair is given. So it now looks very much like this. Only thing is this is a linear in linear geometry, whereas this is bent one, have a bend here. So this is the actual geometry of the molecule, but for Lewis dot structure it is not that important to have the correct geometry of the molecule. Okay, the correct geometry of the molecule we will learn later. So that's all about the Lewis dot structure as an introduction. In the next parts we will see few more examples on how to draw the structure of a molecule or a species using Lewis dot structure. Okay, thank you.